Hello and good morning. We're going to talk about compound inequalities today. I found out it's like it was on my chair. Okay, so what does it mean to be a compound inequality? And these are actually really pretty common. But we're going to start with the idea of bounds. So yesterday I talked about my fence versus my neighbor's fence and how do I say where my property is. Okay, so I'm just going to literally draw you a picture. So here's my house. Let's just say we're gonna do like little kid. Here's my house. You know, when you're a kid, or at least when I was a kid, this is what we would draw. This little box with a triangle on top. And then I would always draw this with a fireplace and chimney, but I don't have a fireplace. But everybody has some sort of a flue because that's where, like, when you heat your house, the heat escapes somehow, like the extra whatever. So the gases and stuff. So there's my house. And I have my house goes here into the backyard, and there's a fence. But we're going to do a 2D picture, okay? And over here, there's this fence, okay? This fence is mine, my fence. Here's my neighbor's house over here. They can have some stairs. Again, it's 2D, okay? There's my neighbor's house. They get a circular window. It's a hobbit house, okay? This is my fence. Now, here's my neighbor's house over here. Something happened to that house, but it's 2 stories, okay? And no, like a little kid, you don't have to draw like a line in between the stories. It actually just says 2, and this one does have a chimney, lucky them. Okay, but this is my neighbor's fence. So my yard goes from here to here. This is my property. Why do I care about that? Because, you know, if there's something, a mess right in here, the city comes and assesses me. But if the mess is like right there, that's their problem. And if the mess is like right there, that's their problem. Now, there's a big tree here in real life, IRL, that if something were to fall onto this, it's technically my neighbor's fence. Although it technically fell from my tree, so I still have to pay for it. Ugh. All right, these are why all these weird laws exist. All right, so why am I drawing these pictures, and why are we talking about fences when what we're really talking about is compound inequalities? Well, compound, much like the word, probably just means it's a little more complex, okay? It has extra things going on. But it's still this, what we talked about yesterday, this inequity, right? We need to know bounds on something. We're not talking about a singular value. My property is not a dot on a landscape. It's a space, right? And it has bounds. So what that would mean for us in solving is, let's say my house is an algebraic expression. We're going to say 3x plus 7, okay? So we learned our symbol, variable. This symbol means sum, addition, right? So 3x plus 7, this is going to be my fence. I'm going to be or equal to. We might end up with some fractions here. I'm going to try my best to not have fractions, but, I'm making this up from whoop, so we'll see. 3x plus 7 is less than or equal to 16. And it is going to be greater than, let's see here, -5. Yeah, I did that. So now, let's talk for a second here, because now we're in a new realm of things. As I talk to you about, oh, that's a glare on the light. Dang. I'm going to have to zing it like this. Can we still see? Can everyone still see? How you doing at home? You have your coffee? You have your shiny morning face? Oh, it's hot. So I've been talking about finding where your relationship is, right? And there's been one. But in compound inequalities, there are 2. There's this one, right? And there's this one. What the actual, Becca? What the actual? Now, could I have this all flip-flopped? Yeah, you totally could. But we're going to start relatively simply because -5 is clearly less than 16. And we have this left to right thing going on with our numbers that we're trying to keep. Okay, for our brain's sake, for order's sake. So this is what we're looking for, right? Where is my property? Where's my house? What's my yard? What do I have to mow? And where can I plant flowers? Okay? So we still have this thing. Now, you could separate this and solve this part, or you could separate it and solve this part. And there are some problems you have to do that. But this particular one, we're going to say example. In this particular one, we can do it all at once if we're careful. See, we're building quickly. I know we're exponential growth here with math. We had a real low, slow line. Well, we had low, slow line. And now we're at the turn, much like COVID in like March. Okay. So how do I solve this? We deal with the numbers later. How do I solve this? Well, I want x by itself. X was multiplied by 3 and 7 was added to that. Okay, I don't care what these things are right now. They're not a part of my analysis. They're boundaries. They're boundaries that will change as this changes, but they have to change harmoniously with equity at the same time so that we keep this relationship true. Okay? So here I'm analyzing this, and I know I need to subtract 7, but I have to then do it to all parts. You see this? Let me get my blue back. So let's start with the middle, because that's what we're trying to solve for. This goes away, because any number subtracting itself becomes the identity under addition, which is 0. And we don't usually write 0 down. We could, but we're not going to. So this gives us x inside of here. Okay? This stays the same. This stays the same. Those are our relationships. So then over here, 16 minus 7 is what? This is where knowing our counts, all of math is counting, helps. Well, it's best if we have this memorized. It's easier. That's 9. But if you need to keep practicing that, that's okay. Keep practicing it. I'm doing it under the assumption that some of you have it memorized because those are prior lessons. -5 minus 7. Oh boy. Now, if you're like me when I was learning this when I was younger, I would still sketch out a little number line to make sure I did it right. Plus, minus, 0. I am already 5 in this direction, and I went 7 more in the negative direction. That means I'm getting a larger value, but it's negative, and that's -12, right? 5 and 7 are 12. We have this. Now, here we have it. 3 times x is less than or equal to 9, and it's greater than -12. Okay, I know we're still getting glare. Sorry. So, but now I want to, what's the operation here? 3 times x. So the inverse of multiplication is division. Divide by 3. Divide by 3. Divide by 3. Okay? 3x divided by 3, anything over itself, is the identity under multiplication, which is 1. X. This stays the same. This stays the same. 9 divided by 3. 9 things in 3 parts is 3. There are 3 in each part. 12 things in 3 parts have 4 in each part. But it's negative, okay? Now we know the boundaries of our x. If we were to graph this on a number line and not say where my house is, okay? We would do this. We did this yesterday. I suppose I shouldn't use words like that because you can be watching this in any order, but that's what I did yesterday. So, let's start with this one. 1, 2, 3. Is it an open circle or closed? So we have our circle at 3, right? But is it open or closed? Does it count? Is it my fence? It's my fence. I fill it in. If something breaks that fence, I'm the one who ends up having to fix it. I mean, it's my problem. Even if I get someone else to pay for it, it's still my fence. -4. 1, 2, 3, 4. Is it my fence or my neighbor's? It's just strictly greater than. This is not mine. So it stays open. Now, this is kind of easy because we're talking about fences, but again, so I just have the boundaries right now. Let's go back to this idea. X is, this is a whole phrase. So if I did what we were doing the other day, yesterday, and I said x is less than or equal to 3, I would say all of this, right? I would fill all of that in. Can you see it? I would fill all that in, right? Less than or equal to. And if I said strictly x is greater than -4, I would fill all this in, right? Well, now I've filled in the entire number line, and I didn't actually do anything. So this is the essence of compound inequalities, and I'll go back to my neighbors, okay? If this neighbor over here, they're really awesome people. If they're concerned of just their relationship with me, they would tell their friends, oh yes, this is our yard, but the moment you cross this, it doesn't belong to us. It's very vague, and that's true. It doesn't belong to them. So for their concern, they would fill all that in, because this is the part they care about. These neighbors over here would say the same thing. Over here, from that direction, it doesn't belong to us. But again, it's vague. It's not specifically about my house. So they also would fill in everything in that direction, and it would be true. But the compound nature of this is both. So I am both less than or equal to 3 and greater than -4. Okay? So I only fill out in between these things, however you want to do it. I've seen everything under the sun with kids. Right? It's really thick. Now I have shown my bounds are from 3 to -4. This is the same as this, which ultimately is the same as this. Now, normally I would say, any questions? But you're all out there, and I'm in here, and you guys are doing your thing, and I'm trying to do mine. And it's weird. But if you have any questions, of course, we have our digi, digi world. We'll try to figure that out. I don't know how many of you guys are going to see this, but I know it's rough right now, but you're doing a great job. Just don't worry about it too much, okay? It's going to be fine, really. Just do your part. All right, cheers. I'll see you later. Happy coffee. I'm going to go get my son and myself some breakfast.